Okay, so good day everyone. We have the topic logic circuits. Okay, so logic circuits are the basic building blocks of our computer. Okay, so logic gates or circuits. Logic gates are the basic building blocks in a computer world. Okay, or the electronic circuits for the computer. Okay, so logic gates, we have four basic logic gates. Six basic logic gates. We have the yes gate and the not gate. So let's discuss yes gate and the not gate first. Okay, so yes gate. Okay, yes gate, a digital electronic device or component that the output is the same with the input, also called buffer gate. Okay, in the computer world. So the symbol is simply a triangle. We have the input and the output, input A and output Y. Okay, so the input is always the same with the output, so meaning A, input to yes gate, the output is 0, and if 1, input to 1, the output is logic 1. Okay, the next, not gate. Okay, not gate defines a yes gate with a bubble. Okay, this is the bubble. Okay, meaning this is not. Okay, a bubble itself is also a not gate. Okay, the bubble itself is also a not gate. Okay, that inverts the incoming digital signal, meaning if the input is A, therefore the output is not A. Okay, so in our table the output is Y. Okay, so this is the truth table, also called inverter gate, or sometimes called hex in computer world. Okay, so we have, if the input is 0, then the output is 1. If the input is 1, the output is 0. Okay, the next gate or gates are the OR gate. Okay, the next gate are the OR gate and NOR gate. Okay, so what is an OR gate? Okay, so this is our OR gate. This is our OR gate. This is the symbol. Okay, so an OR gate can have 2 or more inputs. Okay, logic gates can have 2 or more inputs but only 1 output. Okay, so take note. Okay, so logic gates can have 2 or more can have 2 or more inputs, but logic gates can have 2 or more inputs. Okay, so input and only 1 output. Okay, so that is logic gates. Okay, so take note for the logic gates. Logic gates can have 2 or more inputs but only 1 output. Okay, so OR gate, a digital electronic device or component that performs logical sum function in a computer world. Logical sum. Okay, so the output is high or logic 1 if one of the many inputs is high. Okay, so meaning in our truth table, 0 plus 0 is 0. 0 plus 1 is 1. And 1 plus 0 is 1. And 1 plus 1 is also 1. Okay? The output is high for logic 1 if and only if one of the many inputs is logic high. So the inputs are 2, 2, 1. So therefore, the output is 1. Only one. If one of the input is 1 or high, the output is high. That is other definition for the OR gate. Okay. The next, NOR gate. Okay. An OR gate with a bubble. Okay. The output is low for logic 0 if one of the input is high. Okay. If one of the inputs is high, the output is 0. Okay. For example, A plus 0 plus, this is your input A, B, and this is your output Y. Okay. So 0 plus 0 is 0. Then inverting that. Okay. So bubble itself is an inverter. Okay. So 0 plus 0 is 0. Inverted the 0, or that will become 1. Okay. So 0 plus 1 is 1. Invert that, so that is 0. 1 plus 0 is 1. Invert that, will become 0. Okay. 1 plus 1 is 1. Invert that, will become 0. That is the NOR gate. Or NOR gate is an inverted OR gate with a bubble. Okay. So take note of this symbol and this symbol for OR gate. Okay. Then the next, we have the AND gate and the NAND gate. Okay. So what is a NAND gate? Okay. So a NAND gate, a digital electronic device or component that performs logical product function in the computer world. Okay. So the definition, the output is high if all of the given inputs is high, otherwise the output is low. Meaning, we can have an output of 1 sa 1 that all of the input must be 1, or all of the inputs must be high. Okay. So logical product. Okay. So this is the symbol of AND gate with a letter D. Okay. So input is A, B, and Y is the output. Okay. So 0 times 0, and that is 0. 0 times 1, and that is 0. 1 times 0, and that is 0. And 1 times 1, that will become 1. Okay. So take note, or take a look at the table. All of the input is high, therefore the output is high. What is an AND gate? Okay, the next is an AND gate. An AND gate, what is NAND gate rather? An AND gate with bubble. Okay, so another AND gate with a bubble will become your NAND gate. Okay, the output is low if one of many inputs is low, or logic 0. Okay, sometimes called inverted AND gate. Okay, inverted AND gate in digital world. Okay, so input is A, input is B, the output is Y with the bubble. Okay, so take note of this symbol. Okay. Let's solve the truth table. 0 times 0, and that is 0, and then invert that 0, and will become 1. 1 times 0, and that is 0, invert that 0, will become 1. 1 times 0, invert that 0, will become 1. 1 times 1 is 1, invert that 1, will become 0. Okay. The next, The next is the XNOR and XOR gate. Okay, so we have XOR gate. Okay, so this is the symbol of your XOR gate. Okay, definition: the output is high or logic 1 if the inputs are different, otherwise logic 0. Meaning, if our inputs are different, then the output is high. If the inputs are the same, then the output is 0. Okay, so that is XOR gate. Okay, so let's discuss the truth table. 0 XOR 0, therefore the output is 0. 0 XOR 1, and the output is 1. 1 XOR 0, and that will become 1. 1 XOR 1, and that will become 0. Okay, so the definition: the output is high or logic 1 if the inputs are different. So this one, 1, 2, 3, and 4. Okay, so number 1, the inputs are the same, so the output is 0. Number 2, the inputs are different, so therefore the output is 1. Number 3, in your table, the output is different, so therefore the inputs are different, so therefore the output is 1 or high. Number 4, the inputs are the same, so therefore the output is 0. Okay, and the last, we have the XNOR gate. XNOR gate can also be defined as inverted XOR gate. Okay, so XNOR can be defined as inverted, okay, inverted XOR gate. Okay, XNOR is an inverted XOR gate with a bubble. Okay, or XOR with a bubble, and that will be your XNOR gate. Okay, so take note of this symbol and the other symbol, okay, for the XOR gate. Okay, so the definition: the output is high if the inputs are the same, otherwise logic 0. Okay, so for 0 XNOR 0, that is 1, since they are the same. Okay, this is number 1, number 2, number 3, number 4 inputs. Okay, so number 1 inputs, the inputs are the same, so therefore the output is high. Okay, number 2, the inputs are different, so the output is 0. Number 3, the inputs are different, so the output is 0. Number 4, the inputs are the same, so therefore the output is 1. Okay, so take a look. We invert 0 will become 1, invert 1 will become 0, invert 1 will become 0, and invert 0 will become 1. So therefore XOR is an inverted XNOR gate is an inverted XOR gate. Okay, so you can review the video, and you have your notes on chapter 4 of our module. So I hope you understand the discussion through this video. Okay, so thank you, and God bless us all.